I am Ramakrishna Rama, Director for PowerEdge Enterprise Servers Systems Management Embedded Software. The products iDRAC, Chassis Management Controller, Lifecycle Controller, that engineering development happens out of Bangalore, and I head the development engineering from here. The topic today is hyperconverged infrastructure, pros and cons. Right, the data center is going through a lot of changes because of digitization, because of the demands on the infrastructure. Last few years, in terms of automation, in terms of modernization in data centers, that is on the high scale. And hyperconverged infrastructure is a new framework which is gaining momentum, which already has gained significant momentum and market share. And we will talk about the benefits, advantages, and at the same time what are all challenges in terms of technology, in terms of products, in terms of business. Right. So now I will let my panel members to have a quick introduction, and I am privileged to have an interaction with such a fantastic group. And quickly we go over introduction of each member. Start with Murali.
Yeah. Hey everyone, good morning. I'm very glad you all are here to know more about hyperconverged infrastructure. I head the platform solutions organization in Nutanix India, and what platform solutions team does is basically enabling our customers to get the hyperconverged solutions into the data centers and everything that's to do with starting from getting the systems up and running and to the lifecycle management, the ongoing software release updates. The team in Bangalore owns a lot of these responsibilities, and I head that particular product group.
Mohammed.
Hi, morning. This is Mohammed Hayath. I'm from VMware. I lead the systems engineering for the South region. So mostly I'm on the field with my team. From my personal perspective, I cut across all the technologies what VMware gets to the market. Thereby, more from a sales, standpoint, and that's what I support the field on. Right. So.
Hi, good morning. I am Raveendra. I am the technologist for system management. So on the Dell server side, so because the software defined everything is coming, the system management aspects of it gain a lot of importance, because whatever you are getting, whether it is a storage box or network box, behind the scenes is the server. So we do the technology architecting and the system management stuff for the Dell servers.
Okay. Fantastic. So before we get on to the pros and cons of hyperconverged infrastructure, let us look at what it is. What is hyperconverged infrastructure? What is the evolution? What is the technology? How it is helping the digital infrastructure or IT infrastructure, or be it data center, be it cloud, be it enterprise IT architecture. So let us look at what it is. What is the difference between converged infrastructure and hyperconverged infrastructure? So Murali, if you can tell us what's actually the evolution and what is it trying to address?
Sure. Thanks, Rama. And we feel proud to talk about hyperconvergence because prior to Nutanix there was no term called hyperconvergence, right? It was Nutanix who pioneered the technology, and now it's become a phenomena in the data center space. So to give you a very simple example of what hyperconvergence is, it's the smartphone in your hand, right? Traditionally, if you see, there has been a different device for a different purpose. You had a camera, which was a hardware. You had your purpose-built GPS by companies like TomTom and Garmin. You had your purpose-built MP3 players like your iPods and things like that. And so everything, if you see now, has been consolidated, and it's turned into a smart device in your hand, which is essentially a very standardized hardware. And what you do with that is install apps. So if you want a camera, now it's an app, right? If you want a GPS, it's an app. And if you want a music player, it's an app, right? So everything has been eliminated in terms of a traditional camera, a film roll, be it a GPS or be it be it things like music players. That's exactly what Nutanix has done to data centers today. What we have done is we have taken this notion of hyperscale and put a consumer grade design on top of the standard x86 servers, and we said if this level of disruption can happen in consumer space, right, why can't the same level of disruption happen in data centers? And if you need to book an Uber cab, all you need to do is 2 clicks, right? You just open the app, you just say what's your destination, and then the cab will arrive. So if consumer level consumption has been made so simple, why should data centers be any complex? Why should data centers be so complex that you need 3 or 4 or 5 different administrators and 5 different vendors to power your data center, right? The 4 main components of any data center is your storage, the compute, the virtualization, and the networking. What we have done is we have taken a consumer grade approach to all of these. So the hyperconverged infrastructure in general is basically a commodity hardware, commodity networking running, and all the specialized features that you require is essentially software, right? So you take your standard x86 server from any of our vendors like be it Dell, HP, Cisco, Lenovo, and standard 10 gig networking switches or standard 40 gig networking switches, and you don't need any more specialized hardware, you don't need any more specialized storage controllers, specialized storage devices, and everything that you want in terms of your traditional storage capabilities, be it SAN or filers, or be it in terms of your running virtual machines. You want to run VDI, you want to run server virtualization, you want to run SAP HANA, you want to run Oracle RAC. Everything is powered by the software layer. So that's exactly what it is, that it's bringing the notion of convergence to the next level, where even things like hypervisor is no longer need to be sold or purchased, right? So we have kind of brought everything in a software layer. And what are the strong positives of this is because everything is software, we can roll out new features, new updates, new capabilities all within one simple update, right? The way your apps get updated on your smartphone, you install Uber and you sleep and wake up in the morning, maybe your Uber app has already updated to the latest version with newer capabilities. We have brought in that level of simplicity even into upgrades in data centers, right? Traditionally, upgrading a data center was a very complex operation, right? You need to bring different administrators together. If you want to update your server, you have to be really worried about if I'm updating anything on the server, will my network needs to be taken care? Should I coordinate with the storage admin to make sure that storage services are not affected? So a lot of these complexities exist when you deal with this infrastructure from different vendors and different technologies. With hyperconverged infrastructure, you just update your software in a non-disruptive way. Your applications are running, your virtual machines are running, and your app has just updated.
So basically, HCI has simplified, data center design, right?
Yes.
And everything is in software. You don't have to have dedicated hardware, be it compute, network, or storage.
Right.
Okay. Fantastic. So Mohammed, now everything is software defined data center, software defined storage, software defined networking, software defined compute, or virtualized server. So how HCI is basically making everything software defined?
Yeah, like my colleague mentioned, it's all software defined, right? And if I just get back into history, software defined data center was coined by one of our ex CTOs at VMware called Steve. So the whole idea was simple, as he mentioned. I won't repeat it much, but it's all getting control of the hardware through software, including updates, including everything. So if you look at it, and I'm again going to repeat this, so the 4 components, one is the compute piece, one is the storage network, and the management piece. When convergence came into picture, it was more, all put together, but it was not a single software layer. Then we moved into hyperconvergence, wherein we primarily started off with the compute and the storage layer, right? So we defined, storage and the compute at a software level. That's what HCI came into being. And now, because we didn't want to leave out the other, pieces of the, puzzle, which is the monitoring, management, automation piece, and the networking piece. All these pieces, if you look at today, you find all these pieces software defined, right? So all the components which are required to run a data center are completely software defined. Hardware agnostics, which is very important from a customer standpoint, because he or she, when they build up a data center, they really need not worry about what hardware I'm going to buy, because you're going to get locked into that particular hardware and with the ASICs which you're going to use. So commodity hardware is something which the industry has really accepted it, and all this runs on x86 platforms. So a combination of commodity hardware with x86 platforms, on top of which you run a pure software defined layer, is what you'll get in the data center. And like my colleague mentioned, it is irrespective of what industry you're in, right? Most of them are actually looking at defining everything from a software perspective. If you take, for example, Tesla, right? Most of the cars are software defined because they can do upgrades of their cars and whatnot. And, everything is, about software. So from a data center standpoint, so hyperconvergence becomes very important and key. And just to add, if you look at it from our perspective, from a VMware standpoint, the vision has been software defined data center, so that you can actually have any application, irrespective, right, run on any device. Today you just don't have a laptop. You have Mac OS, you have Windows, you have Android, you have iOS and so on, irrespective, and rugged devices and IoT. So there are so many things. So irrespective of the device which you're going to use, any application, and you need to have the flexibility to run on any cloud. It could be an on-prem cloud or it could be off-prem. Like it could be an Azure or AWS or IBM SoftLayer, whatever the case may be, right? So the flexibility which it gives to the end users and to the corporations and organizations is tremendous. And one of the pillars which we define is called the modernization of the data center. And within modernization of the data center is the hyperconverged theme, which becomes a very, very important and key and critical piece of whatever we are trying to sort of stack into the overall architecture.
Thanks, Mohammed. So can the same be achieved without virtualization? Because the x86 server is the base where entire software, be it your switching software, network software, server software is running, and where every component is emulated. But how important is virtualization?
So if you broadly look at it, virtualization is a very important piece. And if from a virtualization standpoint, compute virtualization was innovated some 15 years back by VMware. And if you look at today's market, whether it's global market, APAC market, India market, 80% of all the customers, right, whether it's government, defense, corporations, everyone, right, 80% of them have done compute virtualization. So compute virtualization becomes a very important and key ingredient of whatever we are trying to do. I mean, there'll be options of doing it on physical, but it really doesn't make sense to, do that. Somebody may come up with something, but it really doesn't make business sense, economic sense, and whatever you may want. To that, we added the storage piece as phase one. And now if you look at in today's networks, you have all the, monitoring, management, automation, as well as networking completely defined on software, which basically also brings me to the fact that networking no longer needs to be your high-end sort of network boxes. It just can be a plain vanilla switch which can just forward packets from point A to point B. All layer 2, layer 3, SSL VPNs, all those functionalities can be defined at the software layer itself, and you can do the complete network, stuff.
On a general hardware.
On general hardware, absolutely, You're right.
Thanks. Now let's go to Raveendra. Now Mohammed touched upon monitoring, management, configuration, deployment. So how important is systems management for hyper-converged infrastructure systems and platforms?
Yeah. So all software is good, software defined is good, but if you don't have the underlying layer, the underlying is hardware, right? If you just have a hardware, if they have to say all vendors they have to support, without system management they can't do it, right? So we are not seen anywhere, but for you to define the software enablement, software defined everything, we have to do certain stuff on the server software or the system software. What all we do, right from the time when you get to the factory till you take off from their support life, we have to be all around. What all the steps we do, we have to deploy, because when you say you want everything to be available all the time, and most of the time we'll say cloud, elastic and all that. So that means whenever your load is increasing, you say just spawn off one more VM, spawn off one more container, like that you will be saying. When you reach a limit, then you say, okay, I want another system with this operating system or this hypervisor or whatever that could be. So deploy is an important step that we need to do. At the same time, both of them touched upon the upgrade, right? All of your application, each of your application requires certain kind of a firmware levels or the driver levels or the application levels to be there. That means we have to be able to maintain that compatibility, because if your hardware is not supporting something that which your application requires, then obviously you will not get your performance. That means update has to be seamless. Of course, you will not see us right in front, because both of my colleagues have said their layers will be front-ending you. But behind the scenes, this is what is happening. And then you want to know your hardware is actually functioning or not for those layers to work. And sometimes the costs involved are not just the compute. You have to look at whether the temperature is growing or whether you have to cool down that equipment, something like that we have to do. That means we have to constantly monitor your equipment. And also, when you're doing the maintenance phase, right? So, though we say everything is available all the time, essentially what is happening is there is some maintenance phase, very small window, but very critical window. That maintenance phase also we have to do. And all being hardware, there are failures, there could be failure, and you have to replace. The servicing also comes into the play, right? And nowadays the servers are designed in such a way that you can pop out, pop in, including the power supplies, right? So to manage all this in a seamless manner, so that whatever my colleagues have described, that functionality is offered to the end workload, we have to do all this system management. So that is the role of the system management. It's not seen as the front end, but without this, all this software defined is not possible.
Fantastic.
So one point. So since Raveendra mentioned about failures, so one important design consideration that I'd like to tell with respect to hyperconverged infrastructure is, traditionally the servers and the data centers, when people think of the infrastructure that needs to power data centers, the focus has been to build things that don't fail, right? The focus, like any server vendor, any large enterprise, if you see, there will be like something called as your 100% availability kind of technologies,
High availability.
So that was the core theme of data centers until HCI came into picture. Once HCI came into picture, the approach we have taken to the design is that we assume the hardware will fail, and that's exactly the point Raveendra mentioned, that hardware will fail, right? Every hardware has a life. So the hyperconverged infrastructure is primarily designed assuming hardware will fail, and we don't try to design software that will say how can you prevent issues from happening when hardware fails, but rather even software will assume that things will happen, things will go bad, shit will hit the fan, and you have to take care of that. And that's where the whole distributed systems come into play. It's a very complex technology. Distributed systems in general is one of the most complex pieces of computing, and that's where we bring in a lot of these distributed system concepts into play, where we assume the hardware will fail, and when one hardware fails, how do you bring resiliency into software while that hardware is replaced using the technologies and enablement that the platforms have done. So that's the key difference.
Okay. So Raveendra, as an add-on question, how much is automated? Because we live in an era of automation. So systems management, understand if something goes wrong, how early you detect and notify the customer, and then recovery and the other actions take place depending upon the situation and the eventuality. But how much it is automated?
It's actually 100%. So if you look at it today, all of your data centers, it's a no man's land. If you go to any data center, visit that, actually they won't even allow you to get inside. That means completely automated, right from onboarding till the end, right? Everything is automated. If in the absence of automation, you actually can't do anything. So in the data center, if you are expecting any kind of employees, there might be one or two, mainly to replace the parts. That is the only thing they do. That's also a little bit less. But that is the failures when we are talking about, don't think that the failures are at like 50%, 60%. No, it will be at 0.1% failure rate. But those failures also needs a physical intervention. Only for that, we need to do that. So an interesting story I can give you. We were working with a lot of data centers, right? So one of the time we got into a case saying that your software is not working. Then we said, okay, why don't you go and insert a pen drive into your server and your problem will go away. That's what we suggested. They said, are you kidding? I asked, what do you mean by that? They said, the person I'm talking to is from US, the data center is in Brazil, IT admin is in Philippines. If you don't have automation, none of this is possible, right? So that automation, that is the role of automation, and that's what enables all this fantastic software features my colleagues are describing.
Fantastic. Let us little bit go into the business. So this is a question to Murali, but others also can pitch in. HCI systems, can we use it in any applications or any data center or any IT infrastructure, or will it be suited for starting with small apps and where there is a potential to grow in future? Are there any such kind of use cases where it is aptly fit?
Yeah, so traditionally, way back in 2009-10 time frame, when HCI concept was catching up, and we were trying to build the first HCI solutions, the predominant work load was VDI. Right? We started HCIs with VDI, and even our friends from VMware, when they launched the VMware vSAN, the primary work load was targeted as VDI. But what enabled us to move beyond VDI is, of course, the increase in computing power, the increase in the way we could leverage flash storage, because flash is one of the biggest enabler of HCI after virtualization. And because of that, today we are at a situation where we can boldly go out there and say there is no workload that can't be run on HCI. For example, with Nutanix, if you see, we recently got SAP HANA certified, right? It was unthinkable 2-3 years ago that SAP HANA could run on virtualization. Oracle RAC can be run on HCI, right? So as in when we see, and stock exchanges like NASDAQ and National Stock Exchange, they run on Nutanix, right? So there is no workload that can't be run, starting from your VDI to high frequency trading applications, very both storage and compute intensive database applications, distributed databases like RAC, everything can be run on HCI.
So pretty much anything the current traditional IT infrastructure can be replaced with HCI.
Yes.
Yeah, if I have to add, if you are a small business owner and want to host something, can you dream of having a data center of your own? Right? Usually we'll say it's a huge thing, we'll host somewhere. But with a hyperconverged, you can start with one server and you can go on adding as you are growing, right? That way your initial costs are low and you can actually increase your data center capacity. Whatever my friend was describing, all that can be done without much of an investment. From that perspective, HCI is the key factor.
Yeah.
If you are starting small, and when you grow big, obviously you can go to the bigger data center and then you can move all that. So from that perspective, this is very beneficial even for a smaller player.
Okay, sure.
I'll just extend to what he said. Like my colleague said, you can run any workload, absolutely, right? And in today's world, we have customers running all sort of workloads. No two questions about it. So if you look at the scale, you can start with whatever my colleague said here, saying that you can start very small, and depending on the architecture, it could be a single 2-3 node at least, so that you get redundancy. But the same thing can actually be extended to the cloud, right? And that's a very important piece, because most of the organizations, if you look at the CIOs, they have this in their radar. Some of the applications, most of them have moved it. Some, they want to move some of those applications, and they're looking at a solution which can be sort of a combination of on-prem and off-prem, which is in your public domain. It could be AWS, Azure, and so on, right? So you can extend your HCI, concept, which is there on your on-prem data center, to your off-prem data center, and thereby you can start migrating workloads depending on the business requirement. So it can really scale from on-site or on-prem, and it can really scale into the cloud, and the cloud is purely elastic, right? And you can just keep going on.
So now let's understand the business, because it's a new trend that is happening in in the IT infrastructure space. So last few years, what has been the growth path for HCI? How is it penetrating in the market? Yeah, Mohammed, you can start.
So we have seen a lot of uptake in the market, both globally, APAC, India, everywhere, right? And my colleague can also reconfirm that. Whether it's a very small customer, whether it's a large customer, banking customer, government customers, defense customers, all of them have adopted HCI. And if you do some Google and figure out, you'll also find that the storage market is slowly coming down, whether you like it or not, but that's a fact, right? The fiber channel and sort of SAN connected storage, it's actually flat, or either it's coming down, one of the two. But if you look at HCI, it's actually, there's a huge uptrend, 30, 40, 50% depending on where you are in the market, which part of the globe, there's a lot of uptake. The primary reason for that is the overall total cost of ownership is very, very attractive. And the return on investment on whatever you're going to invest is very attractive. So you're basically going to save a lot of dollars and rupees whenever you get into the HCI model compared to your traditional architecture, because you have combined everything on the HCI. And I won't give numbers, but both VMware and Nutanix have been the leaders, both in the Gartner's quadrants as well as from a revenue perspective. And we see a lot of uptake in the market.
Okay.
Yeah. So so to add on to what Hayath mentioned, right? So in terms of the adoption, what also is very attractive is on your OpEx, right? CapEx is one thing where HCI gives you upfront benefit, right? You don't have to buy equipment from 3 or 4 different vendors like server, storage, virtualization, and at the same time there's a lot of recurring operational costs that come into play, right? Which means that in the traditional infrastructure, which he mentioned that you need to buy SAN and fiber channel, I'm sure all of you would have heard, like there are some company certified fiber channel admin or some company certified SAN admin. Those were specialized roles. That means if you have to run a data center, you need 3 or 4 different admins who understand virtualization, who understand fiber channel, who understand storage. And they were all specialized roles.
In terms of people, in terms of their roles and skill set,
right,
and things.
I mean, even in terms of just physical infrastructure,
right, okay,
you're talking of like a rack of storage, a rack of servers, a different rack of switches and all of these. Now when you have eliminated all of these, we have like amazing consolidation stories where we have been able to consolidate 6 racks or 8 racks worth of equipment into half a rack or just 1 rack worth of equipment. You are saving on your real estate, the footprint in your data centers, the cooling cost, the cost of upfront investment in hardware, because HCI gives you that pay on usage basis. You start small, expand as needed, and more than anything else, the administration cost. You no longer need to have 4 or 5 different admins to manage different pieces of the data center, right? You just have one admin who understands, because it's all consumer grade management applications. Right? That is the simplicity HCI brings in, and because of that, the adoption has gone up so much that Nutanix started the sales in India in 2015, late 2015. Within 2 years, you think of any big name, you think of a big bank like ICICI, you think of big infrastructure company like GMR, you think of airlines like Indigo, everyone is adopting HCI.
That's another interesting question. So if I'm a customer and if I migrate my traditional data center to HCI, what could be my savings in terms of operations, in terms of space, in terms of power and cooling, because these are all the challenges for any data center, right?
So I don't recall the exact, but there's an IDC report on Nutanix website where it's an independent report that published. It's in the upside of 60%.
60%,
right?
So now let us talk about the advantages or benefits of HCI. We have touched upon here and there, but let us consolidate. And at the same time, do we see any challenges or concerns? It's a question to all panel members. So, from your respective functions or respective technology perspective, you can talk about what do you see as benefits, and what you think as challenges.
Okay, you want me to start?
Yeah, you can start.
Yeah, so benefits we already talked about, right? You get benefits in terms of your upfront investment. You don't have to buy term licenses. You don't have to buy perpetual licenses. It's all mostly moving to subscription-based models.
Total
right?
cost
The whole
of ownership.
world is moving to subscription-based models. You get brand new features with just a software upgrade. Traditionally, if you wanted some new feature, vendors like EMC or NetApp had to give you new hardware. Today that's no longer the case, right? You wanted more IOPS, you buy the next node which is more, compute heavy. You want more storage capacity, the next node is more storage heavy, less on compute. So you get that freedom of choice. That's the biggest benefit. The freedom of choice, when the customer has the power to choose, what you want to buy, how much you want to spend, that freedom is, so intangible, right? So, and in terms of challenges, very honestly, when you actually asked me like, are there any challenges? I couldn't think of a lot of challenges. The only challenge that I see is understanding of what HCI can do, right? Because it's a radical new technology in data center space, and there's also little disruption in the employment, right? If, for example, if there's an IT person who has grown up the stack because of a lot of deep knowledge in traditional storage, I mean, what will those people do unless they really reskill themselves or get used to the new way of building data centers and running data centers? That's the only challenge that I see. Those challenges are more because of awareness or disruption it is bringing in the data center space. Otherwise, there are no technology wise, there are no, I don't see any cons in terms of technology.
Okay, what about security? What about the performance when I run the same thing on a dedicated hardware with a dedicated software with a standard x86 server and then everything is virtualized? Can I get the similar performance, similar security aspects?
Yes. So as Hayath also touched about, right, because it's no longer separate security devices, right? Be it load balancers or be it perimeter level security or be it micro-segmentation level security or be it like security of it's much more flexible. And the reason it is much more flexible is because you can build a lot of these algorithms at your hypervisor, at your VM level perimeter as opposed to a server level perimeter, right? Traditionally you could put a hardware firewall. Now every other vendors like firewall vendors, load balancer vendors, they have virtual appliances.
Right.
So what you do is you just bring in that virtual appliance and run it as just another virtual machine. And you no longer have specialized hardware to build network security, right? You're controlling everything through software. So you can define a lot of that using software. So
same performance can be assured, if not better.
Otherwise, like people wouldn't be running Oracle RAC on HCI, right? People wouldn't be running SAP HANA on HCI.
Right. So Hayath, what do you think are challenges and concerns, if there are any?
Yeah, so like my colleague mentioned, I mean, if you look at it from a benefit standpoint, I mean, there are significant benefits.
Yes.
And we touched upon that. I like to highlight, one or two things. One is because, especially from a storage standpoint, with SSDs coming in, and now we have NVMEs and so on and so forth, right? Traditionally, if you look at, on an SSD on a 2.5-inch drive, you can actually get 16 TB of space, and that is phenomenal. And this could never happen in a few years from now.
And it saves power and cooling as well.
Absolutely. It saves power, it saves cooling, it saves space, right? And it has all the performance.
Right.
It has 5 times the performance of a regular HDD, right? Those of you who are using HDD. So that consolidation gives you a lot more efficiency and ability to, things in a small footprint, right? And if you look at a VMware architecture, for example, you can actually have 35 disks in a single node. And if you take 35 disks into, 16 TB, that is half a petabyte on a single node. So a 2U node can run half a petabyte, and that is phenomenal, right? So, and that can scale up to some 64 nodes. So that's the architecture. I won't get into it, but what I'm trying to convey is you actually have a lot of stuff coming in a very small footprint, which gives you the cost advantage, efficiency, and so on. And as technologies have moved, we have NVMe, right? And if you look at the tape drives used to give 800 Mbps of throughput, but NVMe gives you like 25 times or whatever, 32 gig of throughput. So can HCI support new technologies? Yes, certainly they can, right? So we have support of NVMe drives with HCI technologies, irrespective of who the vendor is. But so a lot of advantages from that perspective. The only challenge what VMware saw was a lot of customers whom we spoke to, a lot of them have in India as well, migrated to the cloud. And they had to move their machine formats to Amazon or Azure and all that stuff. Whereas the on-prem machine formats are different, which is the VMDK files, if some of you do understand that, right? So that was an issue because customers could not actually move their workloads onto the cloud because they want to go into the cloud because of efficiency reasons, right? You can just burst and come back for 2 days, 4 days, 10 days, whatever, or probably you can stick there and come back. But that migration is a very big challenge which we foresaw. And that is the reason we came out with something called VMC on AWS. Wherein you have the entire VMC stack on AWS. So no matter, who the user is, if he wants to use a particular, VM either on-prem or on the cloud, now he has the flexibility and availability. And that required a lot of security, like you mentioned, and you can have the same set of security, micro-segmentation, load balancing capabilities, etc. across, your infrastructure. So that becomes an extended hyper-converged infrastructure, which we call the hybrid cloud. Right, and all these are sort of more and more benefits itself. There was a challenge which we tried to address, but those are things which I thought will probably enters the audience.
Yeah, Hayath, can you touch upon multi-node or cluster environment? For example, high performance computing. So how HCI can fit in there?
So from a HPC perspective as well, I mean generally what we have seen is. People use bigger nodes from a HPC standpoint. Those are not, in nowadays still people, a lot of, industries, especially from the manufacturing segment, if you look at the Airbuses of the world, the, Fords of the world and so on and so forth, they still run a lot of HPC environments because they needed very huge heavy machines because you're doing parallel computing and so on and so forth. But what has happened now is we are also, giving them a complete HCI infrastructure, which is completely virtualized, wherein you can run those parallel processes on multiple VMs to get the same output, right? And we are seeing that customers are slowly moving out of HPC, not all of them at this point in time, to be very frank. Some of them are slowly migrating the path from HPC infra onto a hyper-converged infra with smaller, VM density, more densities, but smaller VM size so that they can get the same output.
Okay, right, thanks. So Raveendra, you can touch upon, challenges, benefits, concerns.
Yeah, when you hear my panelists speak, it looks like hardware has stopped, right? You get that impression. That's not true. So hardware is evolving, whereas the software is going at a rapid pace. So this is a huge challenge for us, right? Even the storage, my colleague was referring, is becoming more and more condensed, and the nodes is becoming very, very condensed. What happens to the physical device? How do you manage and still give that same kind of a virtualization capabilities for them to manage? So that's our huge challenge, right? So hardware is increasingly becoming complex. At the same time, if you look at your applications, right, one thing we are forgetting here is the workload, right? We are never satisfied, right? You give 1 spoon, afterwards you ask for 2 spoons. That's a natural tendency. We become greedier. So our workloads are becoming greedier. When your workloads are becoming greedier, though they are exposing the virtual function, that virtual function needs to be highly supported by the hardware layer, right? So you hear AML, DL, all these acronyms, right? What is that making you? You are getting into much richer GPUs. You are getting FPGAs. You are getting TPUs. You are getting IPUs. All sorts of things are happening. So this is putting pressure on the system management to see how do you still manage, but still give that virtualization benefit that our colleagues are referring to, right? So that is creating more of an issue. And the other thing we are looking at is how much power are we consuming? When you are making these devices richer, they are also sucking a lot of power, right? And that causes a lot of heat. That means your cooling costs are increasing. And are you using the full box all the time? Maybe, may not be, right? So then how do you control this in such a way that your cost still remains low? It should not be that I give you a bait, first you get into this infrastructure, and then afterwards the running costs are high, though you are not using it. So increasingly managing this and managing the complexity of the hardware and still providing the layer for the virtualization layers, or the software layers above is the complexity and the challenge that we are facing.
So that is the reason we have out-of-band management solutions to give the same power what they need for virtualization.
And also the standardization so that they don't have to worry about what we are dealing with.
Right.
We work with the standardized system management interfaces so that they don't have to worry. The actual functionality will be directly assigned to you. So that is the challenges. So as the hardware is evolving, keeping these interfaces same, like our developer community here, we don't want to change any API, right? But underlying things are changing. Still, you want to maintain your API consistency. That is the biggest challenge.
Hey, Raveendra, can you touch upon, because you touched upon ML, AI, so the analytics part of it in the systems management in terms of predictive failures, predictive analysis, right? Can you touch upon that?
Yes. So we do number of things in terms of the system management analytics, right? Because we are not there directly. We don't know what kind of workloads you are running. But if we see that memory thrashing is happening, memory errors are happening due to certain workload, we do know what is happening. And we also predict when the disk is failing, when the memory is going to go corrupt, when you are about to, your OS might go down. All that we are constantly monitoring. If you remember the monitor piece of the system management, we are monitoring all these parameters behind the scenes using the out-of-band management controller like iDrag or ILO in HPK. So all that is being monitored to see what is happening to your hardware. If there is a failure, we're also gone to the extent of ordering your part, because if you have a problem with a part, getting the part takes ages, right? Because you have to raise the code, get that, and then come here, and then we talked about only one administrator, that guy has to be told, this will come and you put. This will take a lot of time. We don't have that much patience nowadays. So we do a lot of this analytics and then we pre-order for you. Not for every customer though, because
whoever has subscribed for that.
Whoever has subscribed, you will get all that functionality. So the analytics we are doing, so the system management that way is two-way of functionality. One is to support you with the latest and greatest of workload what you have. At the same time, use the same technology so that how we can be better to support all the virtualization benefits that our colleagues are talking.
Right. So now this brings an analogy. Earlier when, in the early stages of computerization, the computer systems, initially it were built by, one vendor, where from the silicon to, motherboard to operating system to applications, everything comes from one vendor, total cost of ownership. Then customer only bothered about, how do I make use of it? How do I get my functionality, right? Over a period of time, standards evolved, then multi-vendor approach came in, the technologies have evolved, and then commercial off-the-shelf products came into picture. But now looks like HCI, again we are getting back, even though we are running on a standard x86 server, which is, we are bringing standardization, but at the same time total cost of ownership in terms of, eliminating, multiple specializations. That is still giving the, previous analogy of one solution top to bottom by one vendor.
Precisely. I can give you history of this also, right? And this is a major proof that history repeats itself, right? In the 60s, if you see, there were companies like IBM. Of course, IBM continued to stay on, and then there are companies like NEC and DEC, Digital Electronic Corporation. All of these companies, if you see, their purpose was end-to-end development, right? Like the way mainframes were built, every system based on the business need is to build the system, the operating system on it, the application, and all of this. And Intel came and disrupted that. Intel disrupted this approach of a standard processor architecture. And because of that, companies like Microsoft could come and say that, hey, we are now going to democratize consumption of systems, right? So traditionally, all the players that were playing in complete verticals became horizontal. Now you have horizontal layers. You have x86 processors, be it AMD or Intel, it's the same architecture. You have operating system vendors, be it Linux or Windows, they leverage from the same processor. And all the application vendors now could democratize in terms of competition as well, right? You could buy your office software from Lotus or Microsoft back in those days. So if you see that democratization is happening once again, HCI is giving that freedom for customers to choose which server vendor we want to work with. You want to work with Dell, you work with Dell. You want to work with HP, you work with HP. Traditionally, that was not possible, right? So it's a repetition of history once again.
Sure. So Hayath, do you want to touch upon the skill set, or if I would like to make my career in an HCI domain, so what are all things? Sure.
On the standardization part, our colleagues have talked about you have to be vendor agnostic, and we are also saying hardware agnostic kind of functionality. The way we are providing is by adopting the standards across the board, like Redfish interface, or whether it is a server, storage, or switch, you don't have to worry. Earlier it used to be storage has this standard, network has this standard, server has this standard. All that's gone. Now we are going to one standard that fits everywhere. So that also brings to the point that the software defined whatever we are doing, behind the scenes is one piece with the specific differences in the hardware, but the management interface is the standard. So you're right, that democratization is happening, that standardization is happening.
And also the one management solution that can take care of the entire, So Hayath, you can touch upon.
Before I touch upon that question, I just wanted to, for the sake of the audience, so there's a lot of, discussion and a lot of development happening on containers, right? And that's an important topic. I saw a couple of, wall boards on Kubernetes and all that stuff. So if you look at a hyper-converged infrastructure, you can actually run containers on it side by side to virtual machines. And from a VMware standpoint, the solution what we offer is by default, you can actually run containers on it, right? You can run integrated OpenStack software on VMware and stuff like that. So from a developer community standpoint, containerization is becoming very key, especially for cloud native apps. And that can be actually serviced from the same infrastructure, so to say. So you need not have a separate infrastructure. And because of containerization and native cloud apps and whatever, right, you can either have those on-prem or off-prem anywhere in the public cloud. So the movement of all these container-based apps becomes a lot more agile and easier, right? So that is one thing I thought I should touch upon. So just coming back to your question in terms of skill sets, I think if you look at it from an organization perspective, there'll be a lot of savings from a people standpoint as well. Because instead of having, for example, if you had 3 people, one for compute, and you certainly need one for storage because that person needs to understand, fiber channel, iSCSI, SAN storages, NAS, headers and all that stuff. So you generally have a person for storage, and you most likely have a person for network because network is very complex. If you get into layer 3, OSPF, BGP, ECMP and all that stuff, you really need a person who understands the bits and pieces of all that, right? So you generally, in large organizations, you have multiple such teams. So you have a compute team, you have a storage team, you have a network team, and then you have a monitoring team, you have people who understand containers and all the stuff. So what happens is now is a scenario wherein, from a VMware standpoint, again, if I speak, the storage is actually inbuilt on the kernel of the vSphere. So the compute and the storage is all clubbed together in one software on the kernel itself, and it's not an add-on, right? So you have and there's a product called NSX. I won't go into it, but that gives the capability of networking from a software layer. So the software is also integrated, and that's why it's all hyper-converged. So you have a single person or probably a group of people who understand the hyper-converged, software components, which are all these, modules. And that particular person or a group of people can handle the entire data center, right? So it saves a lot of cost from an organizational standpoint. The skill sets are not very different from what a vSphere is because they're very add-on sort of skill sets and nothing to do with technologies like fiber channel and so on and so forth. A lot of cost saving, and that is the sort of skill sets what people need to have. And from an organizational standpoint, as I mentioned, it's going to be very, very attractive because if you have a large data centers where they had some, say, 100 people, they can actually reduce it to 10, which basically means you're doing the entire same data center irrespective of where the data center is with the people of with 10 people sitting here in India, right? Remotely getting in, like he said, hardware can be anywhere and the people can be anywhere. They just remotely log in and do the stuff. So a lot of advantages, and those are the sort of skill sets which you would require from a hyperconverged standpoint.
So we can conclude here. So yeah.
So from a skill set, from a system management perspective, we can't expect that the world will stay at the same place So the system management people also need to learn all the latest and greatest technology. So we use right from C or the basic, that kind of a thing, all the way up to whatever technologies you can think of. All of them are there in our system management stack. So from that perspective, our skill needs are whatever are coming. So whoever is getting that system management, because as the software and hardware is evolving, as we have to keep up, our system management software also has to keep up. So the skill set, whatever is evolving, is the answer that
so up to date with the technology.
Yes.
Yeah. So we can conclude here and we can take on questions. We have few minutes left. We can take on few questions. Yes.
They both stand with respect to each other now and going forward.
So if you look at HPC, you have a very fixed set of constraints that you have to, or the service requirements are very strict, right? So you can't be saying I will scale or anything. That's not the way. You want the response in a certain time. So HPCs, when you look at it, it's for a particular problem, you design a particular HPC cluster. Whereas in a HCI, you are looking more at a generic workloads, right? Of course, you can run these generic workloads there, but the service constraints are a problem. So that's why when you look at HPC, let us say manufacturing HPC, if you are manufacturing a Tesla car, in that plant, if they have a HPC, they will have HPC, not a HCI usually, because you cannot say, this computation, I will take that much time because something has gone. That requirements are not is a problem. And also when you fast forward to a connected car example, maybe you won't go for a HCI if your braking inference has to come from an edge. You might not go. So there are cases where HPC is better, there are cases where HCI is better, but from a cost and evolution perspective, HCI is better suited for most of the problems, but there are always certain set of problems where you need a HPC, like weather modeling or manufacturing or a medical. So there are certain cases where you have to go for HPC.
I'd like to add on there. So, for example, a lot of our customers run HPC. The advantage with HCI is actually that we run GPUs as well, right? It's not that HPCs run only on traditional x86. On the servers that we actually run, if there's a HPC computing requirements, we can add as many GPUs as you want, and you can actually do high performance computing there. For example, Toyota is one of our largest customer. Their entire manufacturing runs on Nutanix using GPUs, right? So essentially it's taking time, because in certain cases the applications may have to be relooked at in terms of how they are written, but it's not that HPC cannot be run. There are multiple examples where HPC is successfully run on HCI. It's just that in certain cases applications may need fine tuning or customization.
So I think all three of us have answers and eagerly waiting to answer that. I'll just take a few of them, right? So the first one I recollect is you said the security layer and the perimeter security. That has been the traditional architecture, right? And I've been, selling these security boxes for quite a while now, and that's been absolutely the traditional architecture where you have a DMZ zone, non-DMZ zone, and so on and so forth. If you look at the traffic within the infrastructure, especially the virtualized traffic, most of the traffic is not north to south bound right now. It is east-west, right? And you know that. So 80% or 70% of the traffic is east to west. And that is the reason you need to have security inbuilt at a VM level, right? And that's where he touched upon micro-segmentation. Micro-segmentation becomes very key. With traditional architectures, you can't protect a VM. Absolutely cannot. You need to go into an external network, do a hairpin traffic and come back even to do an ACL. You just cannot. So that is the reason if you have a software-defined network and security module, each of the VM can be protected by itself, right? The granularity is very, very, lot better. Every VM says, okay, I can speak to the next VM or I cannot. And that sort of granularity is available with HCI infrastructure as of today. So that's why, both security and networking become very important. And the traditional architecture continues only for the DMZ zones. So you will have a gateway or whatever you may want to call it for the north and south bound traffics. But for internal traffic, you need security, as you rightly mentioned, and there are solutions within HCI which can take care of that, right? Number one. Number two, you also spoke about performance. If you actually look at the rate at which the hardware is growing in terms of the CPU, the clock size, the number of cores, the memory it can accommodate, the storage I spoke about, and so on and so forth. For example, in traditional architecture, you use HDDs, right? It can give you 90 IOPS, 180 IOPS, right? If you look at SSDs, it can give you 5000 IOPS, a single SSD. The performance is phenomenal. And if you look at NVMe, I'll just come to it. If you look at NVMe, it is still phenomenal. So a combination of hardware, a combination of all these, technologies. For example, NVMe runs at 32 gig. SAS runs at 6 gig. The backend, I'm saying, the backend path. It's not about the storage. So a combination of all this, blows your mind, wherein you can actually have, latencies lot less and performance in fact better because you're all consolidating in a single cluster. It's not an individual server. You are speaking of all servers, 10 servers grouped together and basically giving you that abstraction layer so that you get all the performance and, less latency which is required. So everything can be done, and we have seen test results, and my colleagues also can share here on the dais. We have seen test results on the HCI infrastructure, which is a lot more better in terms of performance, reduced latency whenever you have this, architecture. I'll just hand it over to them. Probably they have a few more points, and then we can.
So let's look at it this way. If you are looking at efficiency, you are right. When I say efficiency, obviously going through the layers from an efficiency perspective, you are right. Where my colleague is saying is that for the same cost, the hardware is changing in such a way that you are getting your throughput or the parameters, the latency parameters that you are looking at have improved. Hence, so though the efficiency wise you are right, the ultimate output is improving. That's why you don't see the negativity or the layers transition that you highlighted is not coming out. So as a customer, for you, for the same cost, you are getting a better performance. In that mirage of things, we forget that this is happening at the bottom layer. If you want to get the same level of efficiency, you are right, we don't have to go for that. But because the hardware is evolving in such a way that you are not your latencies are not lost. That is the actual way I think. So to add to that, we talked about the system management. You have a door open from the system management where you can get to the box. We said that, right? So that is also a door open for your security. But to prevent that, what we are doing is hardware root of trust we are building. So it's not just a software root of trust, it is a hardware root of trust. So without those, you cannot even enter. So software they explained, whereas we said, hey, nobody is there, you can enter remotely. We also have to take care of that. So we are doing it so by using a hardware root of trust.
So I give you one example, right? Like, if you are able to sell it to any defense, for example, right?
So just to try and attempt answering, So attacks, spywares, malwares, all sort of attacks based on signatures keep happening, right? So it's all about signature based, and that is the reason you had IDS, IPS in your traditional networks. And so if you look at it from a VMware standpoint, we have a product called App Defense. So App Defense is a software product which runs on the kernel, on the hypervisor. So what it does is you have a intended state of a machine, right? Saying this machine is this particular VM is supposed to run this application with so many processes. So it'll baseline that particular, machine. And if there's something which happens other than those processes, it'll actually quarantine them immediately. That is the reason we call it, it can prevent a 0-day attack. Even if there is attack which has happened, which nobody knows, a new signature is not out, it can actually prevent that because it doesn't know it is something which it's not seen. And that is called the intent-based security formation layer, which we have embedded on vSphere. So there are a lot of technologies. It's not that it's not there, but at the same point in time, let's not get into that, because see, this discussion I don't want to disturb. I'm just saying that, so it'll continue to happen. It's not that because security is a threat, people have stopped buying even hardware. Are they not connected to internet? Initially, in my earlier years, I remember, connecting to internet was a big thing because you'd get attacked. Today, sitting wherever we are, all of us are connected 24/7 onto internet. Are we really worried about security? Yeah, there are security issues. We will fix that. It'll keep moving and so on and so forth. So it's a continuous process. There's nothing like you can say this is the process and it'll be done with it. It is not. It's not going to happen. Right? That's why security, you have hundreds and thousands of security vendors, because every day you have new security threats, and we'll keep working on it, and organizations, people will overcome it. There'll be something new. So there are innovations which keep happening, artificial intelligence, machine learning. There's so many things which are embedded on whatever we do. So it's all a combination. There's no straight answer to say, yes, it can be done today and we are done with it.
So just to add to that, why attacks are happening, I think that part of the question was not answered in my view. The number of people who are trying to get into fame to attack and then to do it is increasing ever. So if you are thinking that that population is decreasing, no, it's increasing. So the attacks definitely will increase, and the AI ML portions that we are talking about is how to classify that and prevent whatever we can prevent. So attacks are bound to happen. At the same time, the silly mistakes or the silly kind of attacks might not happen, but very, very sophisticated attacks are happening because the number of people who are employed or who are willing to do that is increasing. So that's why attacks will happen, but all the answers we are giving is more towards how we can reduce that. That's all.